Hello children, how are you all? Okay, hope you all are fine. Yeah, today we are going to study about chemistry, okay? Chemistry unit 1, okay? Right, what is the first unit? Let's see. Basic concept of chemistry and chemical reactions, okay? This is the first unit in chemistry, okay? We think there is a color, we think there is a sweet, we think there is a bitter, isn't it? We think that there is a color, there is a sweet, there is a bitter, but in reality they all are atoms. They all are atoms. So chemistry is everywhere around us. Chemistry is everywhere around us. Okay. In biology we used to study DNA, RNA, like that. Yeah, that is very important for our body function. Like that, in chemistry, atoms and molecules play a major role for each and every function, each and every particle of an object. So, atom is a main basic of chemistry. Okay, do you understand? Right, chemistry is used in various fields, okay, for preparing the cotton, nylon, synthetic fiber, okay, as a pesticide in agricultural fields and in pharmaceutical industries for preparing the drugs and tablets, like that, okay. It is used in refinery oil, chemical industries. In each and everywhere there is a chemistry. Without chemistry we cannot survive. Without chemistry we cannot survive, okay. Let us see the basic concept of chemistry and the chemical reactions in this lesson. Okay, let's go into the lesson. Are you ready, children? Okay. Be careful and very eager to learn this. Next, chemistry is the center of life. How we can say the chemistry is the center of life? How can we say? Tell me. Chemistry is the center of life. It is a very important in everyone's life. Okay. In Tamil, we used to say one quote like that. Unna unavu, udukka udai, irukka idam. Have you heard it? Unna unavu, udukka udai, irukka idam. Okay. Which means food to eat, cloth to wear, and place to live. Isn't it? Food to eat, cloth to wear, and place to live. These are the three basic needs of human life, isn't it? These are the three basic needs of human life. Chemistry plays a major role in providing these needs and also help us to improve the quality of life. Okay? Chemistry plays a major role in providing these needs and it also improves the quality of our life. Chemistry has produced many compounds such as fertilizers, insecticides, etc. that could enhance the agricultural production. We build better and stronger buildings that sustain different weather conditions with modern cements, concrete mixtures and better quality steel. Okay, with modern cements, concrete mixtures and better quality steel. We also have better quality fabrics. So, chemistry is everywhere in the world around us. Chemistry is everywhere in the world around us. Even our body is made up of chemicals. Continuous biochemical reactions are occurring in our body. Isn't it? Do you know? There are many chemical reactions occurring in our body. Chemistry is everywhere in the world around us. Even our body is made up of chemicals. Continuous biochemical reactions are occurring in our body. Isn't it? Do you know? There are many chemical reactions occurring in our body that are responsible for human activities. Then only we are living. We are doing our work by ourselves. So many chemical reactions are undergoing in our body. Chemistry touches almost every aspect of our lives. Our culture, our environment, in each and every aspect, chemistry has a great part. Okay.
The world in which we are living is constantly changing, and the science of chemistry continues to expand and evolve to meet the challenges of the modern world. Do you understand? As our day by day, our life is changing into a modern world, so the chemistry is also going to expand and is also evolving to meet the challenges of the modern world. Chemical industries manufacture a broad range of new and useful materials that are used in everyday life. Examples: polymers, dyes, alloys, gold, silver. Okay, these are used in everyday. These all are chemicals, isn't it? They are alloys. Also used in life-saving drugs, tablets, medicines, etc. For extent, I will say an example. When HIV, that is AIDS, it's an epidemic disease, okay, very epidemic, which began in the early 1980s. Have you heard about it? Patients rarely lived longer than a few years. Only for some years only the HIV patients will live, because on that years there was no medicine for that. But now many effective medicines are available to fight the infection. So nowadays many effective medicines are available. Many effective medicines are made to fight the infection, and people with HIV infection have longer and better life. Nowadays they are living for a long time due to invention of many medicines. These are due to chemistry. Without chemistry, nothing happens, isn't it? Okay. The understanding of chemical principles enable us to replace the non-eco-friendly compounds. What is non-eco-friendly? Non-eco-friendly means that causes harmful to the environment. Chlorofluorocarbons, which is emitted from the refrigerator. Okay. In your home you are having fridges, okay, refrigerator. In that non-eco-friendly compound is ejected, CFC, that is chlorofluorocarbon. It is increasing number of greenhouse effect, like that. So there are many researchers working in different fields of chemistry to develop the new drugs, environmental friendly materials, synthetic polymers, etc. Because that non-eco-friendly components causes harmful to us, but environment friendly materials causes a better society, okay, a safe society. So as chemistry plays an important role in our day-to-day life, it becomes essential to understand the basic principles of chemistry. Okay, it is understandable. It is very easy to understand the basic principle of chemistry in order to address the mounting challenges in our developing country, as chemistry plays an important role in our day-to-day life. Okay, let's see about chemistry, the basic one. Okay, have you understood, children? Right. Now, classification of matter. Okay, I will tell you about it. Okay, have you seen your classroom? Do you remember it? Think about your classroom. How was your classroom? உங்கள் classroom எப்படி இருக்கும்? ஞாபகம் இருக்கா எல்லாருக்கும்? Have you remember your classroom? Yeah. For a minute you think. What do you see there? What are the things you see there in your classroom? Tell me. Yes, benches, table, blackboard, okay, window, duster, chalk piece. Yeah, lot of things. Notebooks. Yes, very good. Okay, what are these things made of? What are these things made up of? These all are made up of matter. These all are made up of matter. Then what is a matter? Matter is defined as anything that has a mass and occupies a space. Matter na enna? Matter அப்படிங்கிறது அது ஒரு பொருள். அதுக்கு வந்து என்ன இருக்கும் அப்படின்னா மாஸ் இருக்குது, அதுக்கு சம் வெயிட் இருக்குது, அப்புறம் அது ஒரு ஸ்பேஸை ஆக்குப்பை பண்ணுது. That has a mass and it occupies a space. That has a mass and it occupies a space. That is matter. Have you understood, children, what is a matter? And all the matters are composed of atoms. All the matters are composed of atoms. Okay? This knowledge of matter is useful to explain the experiences that we have with our surroundings. So, in order to understand the properties of matter, we need to classify them. So, matter தெளிவா தெரியணும்னா we have to classify it. Okay? Classify it. Okay? The two most commonly used methods classification are by physical state and chemical state. Physical state and chemical state. See in the picture, matter is classified into physical classification, chemical classification. Okay? Matter is classified into physical classification, matter is classified into chemical classification, physical and chemical. Further, chemical classification is divided into pure substances. Okay? See the picture. Physical classification, the matter is classified into solid, liquid, gas. Solid, liquid, gas. What is physical classification? Physical classification means by changing the temperature or pressure, we can change one state to another state. Okay? If first ice is there, okay, solid, there is a ice. If you give a temperature, what happens? It becomes a liquid. Further, if you give a temperature, it becomes gas. So, we can change the state of solid to liquid, liquid to solid. That is known as physical classification. Okay. Next, chemical classification. Chemical classification is mixtures. Mixtures is classified into homogeneous mixture, heterogeneous mixture. Okay. Matter can be classified into mixtures and pure substances. So, mixture consists of more than one chemical entity. More than one. That is mixture. Okay. Mixture means a combination, isn't it? So, more than one chemical entity without any chemical interaction, that is known as mixtures. So, they can be further classified as homogeneous or heterogeneous mixtures based on their physical appearance. By seeing the physical appearance only, see the picture. In mixtures, homogeneous and heterogeneous. Okay. First one, there is a green tea. Green tea is a single component. It is a green tea. We can see that it is a homo. Homo means one component. See in the second one, heterogeneous. Hetero means two. Hetero means different. Okay. Homo means same. Hetero means different. So there are different oil and water. See, water is under and oil is on the top. They are not mixing. Okay. That is the heterogeneous. Do you understood? Homogeneous and heterogeneous. Pure substances further classified into pure substances are composed of atoms and molecules. Okay, pure substances are composed of atoms. Pure substances composed of atoms. They are further classified into elements and compounds. They are further classified into elements and compounds. Okay, for element, example is copper, and for compound, the example is copper sulfate. Compound means a combination of two or more. Compound means combination of two or more. In element, it is copper. It's a single. It's a mono copper. In compound, copper plus sulfate. So, combination of one or two atoms of different elements. Okay. Do you understand what is the matter? Okay. Now, see here. The matter is mainly classified into pure substances and mixtures. Pure substances and mixtures, and that is a physical separation. Okay, and the chemical reactions of pure substances are elements and compounds. What is the element? Oxygen, hydrogen, iron. That is an element. What is a compound? Water. Water is H2O, hydrogen plus oxygen. Table salt. What is salt? Sodium chloride. Isn't it? Sodium chloride. So, NaCl. The combination of two elements. What is ammonia? NH3. Nitrogen, H3 hydrogen. So, combination of elements is compounds. Do you understood? What is mixture? Homogeneous mixtures, heterogeneous mixture. Homogeneous mixture means it is a one. Salt water, mouthwash. all the alloys, okay, the solutions of it. But heterogeneous, pizza, Italian salad, solid waste dump, it is a combination of two and it is shown a different. It is mixed and made, okay, it is mixed and made. It is shown a different mixture, okay, it will show a difference in heterogeneous mixtures. Now, let me tell you what is element and what is compound. I already told you, further I will explain, okay. What is element? Element is made up of one kind of atom. Made up of one kind of atom. What is compound? Compound is made up of two or more different kind of atoms. It is made up of two or more different kind of atoms. It is in a fixed ratio. The ratio will not change. The ratio will not change. Do you understood? What is element? Element is made up of only one kind of atom. It has same properties. It has same properties as the atoms that compose it. Okay? But compound has different properties. For example, I will tell you, okay, see the example of element iron, hydrogen, nitrogen, ozone, sulfur, okay. It is a monoatomic unit, it is a polyatomic unit, but it exists only one type of atom. We know that an atom is the smallest electrically neutral particle being made up of fundamental particles, namely electrons, protons and neutrons, okay. Next, what is compound? It is made up of different molecules which contain two or more atoms. Properties of compounds are different from those of their constituent. For example, sodium. Okay, for a guess, you think sodium chloride, NaCl. Okay, NaCl is a salt. Okay, see water, carbon dioxide, glucose, and sodium chloride. Take sodium chloride. Okay, sodium chloride, it is a salt. Sodium is shiny metal. Sodium is a shiny metal. It is very shiny. What is a chloride? Chloride is a irritating gas. Chlorine is a irritating gas. But the compound formed from these two elements. Compound formed from these two elements, NaCl. When these two are formed, it shows different characteristics. It shows a different characteristics as it is a crystalline solid. So, different properties combine together to form another property, okay. But element will have the same property as the atom that compose it. For example, iron, hydrogen, nitrogen, ozone. Do you understood? Now, what is atomic mass? What is atomic mass? Mass of atom, okay. Mass of atom. Determining the mass of atom is atomic mass, okay. Atom is comprised of what? Atom is comprised of protons, electrons and neutrons. But atomic mass, for calculating the mass of atom, what we are doing? For calculating the mass of atom, we have to add protons and neutrons. We have to add protons and neutrons. Because why the electron is not taken into account? As electron is a negative charge, it is eliminated. So, the mass of the atom equal to number of protons plus number of neutrons. Do you understood? Right, that is atomic mass, okay. Now, this atomic mass is the one number that best represents the mass of all the three versions of hydrogen. Here, example hydrogen is given, okay. Example hydrogen is given. This number is weighted average of masses every isotope of hydrogen. See here, this atomic mass is further classified into average atomic mass, relative atomic mass, okay. Average atomic mass is for calculating the isotopes, okay. Protium, deuterium, tritium, for calculating the isotopes of hydrogen or other elements, average atomic mass is used, okay. But in your chapter, you are having relative atomic mass. Relative atomic mass is a mass defined as the average. Relative means it is a ratio. Relative means it is a ratio. So, relative atomic mass is the average mass of the atom. Average mass of the atom by unified atomic mass. What is the unified atomic mass? I will tell you, okay. Unified atomic mass is 1 AMU. 1 AMU. Okay. Now, what is relative molecular mass? Relative molecular mass, okay. Relative molecular mass is the average mass of one molecule of a substance when compared with 1 by 12 of the mass of an atom, carbon 12, or compared with one normal hydrogen atom. See the formula, average mass of one molecule of a substance divided by mass of 1 by 12 of a carbon atom 12. What is mass of 1 by 12 of an atom of carbon 12? That is known as 1 AMU. That is 1 AMU. Unified atomic mass. Okay. The carbon 12 atom is considered as a standard by the IUPAC. IUPAC is an International Union of Pure and Applied Chemistry. Okay. So, C12 atom is a standard one and its mass is fixed as 12 AMU. Its mass is fixed as 12 AMU. Okay. The AMU or unified atomic mass is defined as 1/12 of the mass of a carbon 12 atom in its ground state. Do you understood? The value of 1 AMU is 1.6605 into 10 to the power minus 27 kg. Okay. How much does an individual's atom weigh? As atoms are too small with diameter of 10 to the power minus 10 m, it approximately weighs 10 to the power minus 27 kg. So, it is not possible to measure the mass directly. So, we are using the relative atomic mass, relative molecular mass. Okay. This relative molecular mass is symbol is m. Okay. It has no units and it is the sum of relative atomic masses of the atoms of a molecule. Okay. What is relative molecular mass? It is similar to the relative atomic mass. It is defined as the ratio of molecule of a unified atomic mass unit. Okay. Now see here is an example for relative molecular mass of a carbon dioxide. To find the relative molecular mass of carbon dioxide. Okay. Right. Relative atomic mass of carbon is 12. Carbon is 12. Next, relative mass of oxygen. Oxygen component வந்து 2 இருக்கு அப்படிதானே, CO2. C carbon 1 atom, oxygen 2 atom. So, carbon ஓட atomic mass unit வந்து 12. In periodic table, you can see carbon அப்படிங்கிறதுக்கு கீழே என்ன எழுதியிருக்கும் அப்படின்னா its atomic mass கொடுத்திருப்பாங்க. Okay, 12. Its atomic mass is 12. So, by seeing the periodic table, you can remember by yourself. Carbon oda atomic mass unit enna appadina 12 appadina ungalku therinjirukanum. Okay, you should study from the periodic table. Okay, do you understood children? Right. So, carbon dioxide oda molecular mass calculate பண்ணுங்கன்னு சொன்னாங்கன்னா எப்படி கண்டுபிடிக்கணும்? Listen carefully. First of all, carbon dioxide is separated. C 1 carbon, oxygen 2 O2, 2 oxygen. Okay. Okay. Relative atomic mass of a carbon equal to 12. Next, relative atomic mass of oxygen equal to 2 into 16. 2 into 16. Oxygen oda atomic mass வந்து 16. So, you have to multiply 2 into 16. Write down children. I have given some homeworks based upon it. Okay. Write down carefully. Relative atomic mass of carbon is equal to 12. Atomic mass of oxygen is 16. So, we have to multiply with 2. Now, you have to add these two. The answer is 44. This is the relative molecular mass of carbon dioxide. In this way, you have to find relative molecular mass of various elements. Do you understood children? Right. I already told atomic mass unit, AMU. Okay, what is AMU? Atomic mass unit is used to describe the mass of an atom. For describing the mass of an atom, atomic mass unit is used. Okay, The value of 1 AMU is given here. Okay. Also there is an example. To calculate the AMU in 27 grams of mercury. So 1 AMU by the value 27 grams of mercury. Okay, right. Next, what is mole concept? What is mole concept? In chemistry, the mole is a fundamental SI unit to measure the amount of a substance. What is the SI unit of amount of substance? It is mole. In physics also, I have taught you what is dimensional formula. Okay, in that tabular column itself, the amount of substance formula is given, that is mole. Okay, so mole is the SI unit of amount of substance. Okay, this quantity is sometimes referred as chemical amount. Okay, in Latin, mole means massive heap. So massive heap of a material in Latin, mole means. Okay, it is convenient to think of a chemical mole as such. Okay, right. Often we use special names to express the quantity of individual terms. Okay, for example, I will tell you the example. Okay, see the picture. Roses. Okay, a dozen of roses. 12 roses is there, and 12 balls is there. 12 apples is there. Okay. So what we used to say, 12 roses ku badala 1 dozen roses, 1 dozen ball, 1 dozen apple, like that we will tell, isn't it? We can extend this analogy to understand the concept of mole, that is used for quantifying atoms. Do you understood? It is used to quantify. 12 roses எப்படி 1 dozen சொல்றோமோ அதே மாதிரி chemistryல ஒரு components, to understand the mole concept, we have to calculate the total number of 12 gram of carbon. Okay, 12 gram of carbon in 12 isotope molecules equal to 1 mole, like that we are saying. Do you understood? See the next picture, 1 mole equal to 6.023 into 10 to the power 23. So அந்த 23 ஜீரோவும் போட்டால் எவ்வளோ பெரிய ஒரு நம்பர் கிடைக்கும், isn't it? So that is 1 mole. That is, the large number is deducted into a small word, that is 1 mole. It is the main concept in chemistry. It is a main concept in chemistry. Have you understood, children? Right. Now see the calculation of number of entities in 1 mole of a substance. Okay, see the picture. Name of the substance, carbon C12. First one, you see the mass of the substance. What is the mass of carbon? 12. Okay, next, mass of a single atom is 1.9926 into 10 to the power minus 23. Okay, by dividing 12 by 1.9926 into 10 to the power 20 minus 23, the answer will come 6.022 into 10 to the power 23. See here, for glucose, for potassium dichromate, for potassium permanganate. Okay, what comes there? The answer is molecular. The answer comes by mole. 6.022 into 10 to the power 3. In 4 examples also, the answer is the value of mole. If you know that mole has a standard value, then we can calculate the mass of atom, or we can calculate the mass of a substance. Have you understood? By knowing the constant value. So that mole is placed as a constant value. By knowing the constant value, we can calculate mass of the substance. We can calculate mass of a single atom. You understood, children? Right. Next, Avogadro number. What is Avogadro number? There was a scientist, okay? His name is Avogadro. Okay, he is very known for Avogadro hypothesis. in honor of his contributions, the number of fundamental particles in a mole of a substance, number of fundamental particles in 1 mole of a substance is named as Avogadro number. Okay, after his death only he was honored, after his death. Okay, that is named as Avogadro law. Okay, what is Avogadro number? A mole of any substance contains as many elementary units as the number of atoms in 12 gram of isotope of carbon. This number is called Avogadro number. This number is called Avogadro number. Okay, 6.022 into 10 to the power 23 particles per mole. The mass of 1 mole of a monoatomic element is called gram atomic mass. Okay, for example, the mass of 1 mole of helium atom is 4 gram. Okay, do you understand, children? Now, what is molar mass? What is molar mass? Okay, okay, I will tell you how the molar mass came. Okay, right? Now, the total number of entities present in 1 mole of a substance is already told 6.022 into 10 to the power 23. That is called the Avogadro number, which is named after the scientist Avogadro, okay, who proposed that equal volume of all gases under same conditions of temperature and pressure contain equal number of molecules. This Avogadro number does not have any unit. Okay, does not have any unit. Okay, okay. For example, C plus O2. C plus O2 is CO2. In that reaction, one carbon atom reacts with one oxygen molecule to give carbon dioxide molecule. Okay. So, even though the ratio is based on the number of molecules, it is practically difficult to count the number of molecules. Because of this reason, it is named as mole concept. It is named as mole concept. So, when only atoms are involved, scientists use the term 1 gram. Okay, scientists involve one term, that is 1 mole, and from that it came the molar mass. That molar mass is the mass of 1 mole of any substance, such as atoms, molecules, ions, etc., where carbon 12 isotope is assigned as a value of 12 gram per mole and is particularly useful term. Okay, the molar mass should be accompanied by formula of the particles. Okay, I will tell you clearly. Molar mass is defined as the mass of 1 mole of a substance. Mass of 1 mole of substance. What is molar mass? Molar mass is defined as a mass of 1 mole of a substance. 1 mole of substance oda mass da molar mass. Okay, 1 mole of a substance ku mass da molar mass. Okay, the molar mass of a compound is equal to the sum of relative atomic masses. Okay, molar mass of a compound is equal to the sum of relative atomic masses. It is expressed in gram per mole. It is expressed in gram per mole. Okay, for example, relative atomic mass of one hydrogen atom is 1.008. Okay, then what is the molar mass? The molar mass is same 1.088, but gram per mole. Gram per mole. Okay, or we have to write gram mole to the power -1. Do you understand, children? The molar mass of a compound is determined by adding the atomic masses. Adding the atomic masses. Now, molar volume. Okay, what is molar volume? The volume occupied by 1 mole of any substance. Volume occupied by 1 mole of any substance in the gaseous state at a given temperature and pressure is called molar volume. What is molar mass? 1 mole of a substance oda mass. What is molar volume? 1 mole of any substance oda volume. 1 mole of any substance oda volume, but it is in a gaseous form. In a gaseous form. See the tabular column, volume occupied by 1 mole of any gaseous substances. Okay, at a given temperature and pressure. Okay, see the first condition, 273 Kelvin and 1 bar pressure. What is the volume occupied by 1 mole? 22.71. Next, 273 K Kelvin and 1 atmospheric pressure. Okay, atmospheric pressure, what happens? 22.4. Next, 298 Kelvin and 1 atmospheric pressure, what happens? 24.5. By changing the temperature, by varying the pressure values, the volume occupied by 1 mole of any substance is changed. Okay, do you understood, children? Right, these all are about mole, molar concept, molar mass, element, compound, Avogadro numbers. Okay, later we will see in the next class. Now it's time for homework. Okay, note down clearly. Take your note, pencil. I think you will be having with you. Write down 10 one word from the topic. Okay, in your chemistry 11th book, page number 1 to page number 8. Page number 1 to page number 8. I have taught up to here 10 one words from the topic. You have to write 10 one words from the topic. Next, classification of matter with example. Classification of matter. Draw the diagram and each and every, okay, see the diagram, page number 3. You have to write what is physical classification, and you have to write about solid, liquid, gas, and you have to write what is chemical classification, what is mixture, what is homogeneous, what is heterogeneous, what is a pure substance, what is element, what is compound. Okay, you have to draw the picture and you have to explain each and every parts of that heading, okay, with the example. Next, atomic masses with example. You have to write atomic masses with example. Next, molecular masses with example. Okay, atomic mass, define atomic mass and give example. Example means you have to solve one problem. It is in your book, page number 4 itself. Atomic mass, there is an example. Relative mass, there are 2 examples. Write any one. Okay, what is molar mass and molar volume? Also give the example. Okay, understood? Okay, carefully you read the book and make understand. Okay, have you written, children? Okay, take your own time and study well and write the homework. Each and every one should submit the homework. Okay, take your own time, don't hurry, study thoroughly and write. Okay, thank you, children.